Good morning, everybody. Welcome to the webinar on Agile testing and importance of test design techniques with special reference to orthogonal arrays and pairwise testing. I would like to thank everybody who has joined. I have kept all of you on mute. For the benefit of answering all the questions, we'll take it at the end. Make sure that you keep on sending the questions, and if there's very important or anything that really is something that we need to answer, make sure that you raise your hands on the GoToMeeting. Okay, let's start. When we're talking about this subject for today's webinar, it is Agile testing and importance of test design techniques with special reference to orthogonal arrays and pairwise testing. Does it make sense? Are we confused? Oh yeah, that's what I was thinking, and that's what is the intent, and we'll try to address it one by one. So if you look at it, the entire subject for today's webinar has been broken down into specific areas, and we'll try to address them. The first one is Agile testing. Second is the importance of the word test design. Do we do designing in test? And is a test design technique called as orthogonal arrays, or it is basically also sometimes known as pairwise testing, which has got a huge relevance in the subject that we are talking about, which is Agile software testing. All right, that's how we would do that. Let's proceed. The first term that we are going to discuss is Agile testing. Within that, let's talk about what is software testing. So this definition I have taken from basically Wikipedia, and if you look at it, basically I'm just going to read it aloud for the benefit. Software testing is an investigation conducted to provide stakeholders with information about the quality of the product or service under test. Software testing can also provide an objective, independent view of the software to allow the business to appreciate and understand the risks of software implementation. And there are plenty of other techniques. The intent is to find software defects, okay, and can be stated as a process of validating and verifying that a computer program or an application or a product meets the requirements that guided its design and development. It is working as expected, can be implemented with the same characteristics again, and is satisfying the needs of stakeholders. Now this definition is taken from Wikipedia, and there are similar definitions which exist as per ISTQB or as per basically all the other software testing books we have. Okay. Now, other question that we are talking about is, in this definition also mentioned that there is a process of doing software testing. And what is this process of doing software testing? Now, a fundamental development project, if you look at this particular slide, will have few sections starting from requirements. It will have basically some kind of software design. Then folks will code, and then they would be testing in it, and then go live. And a traditional testing process or a fundamental testing process, that's how basically the testing process is known, begins with a process called as planning for testing. Then there's the next process at a high level which is called as test preparation. It includes some part of the planning and reiterating the plan, analyzing the requirements, and then test designing. And once the coding is complete, the preparation activity should also finish. And then when the code is delivered to the testing team, or the build or the release is given to the testing team, there is a process called as test execution. Now in this process, as the name itself says, whatever we had prepared, we will execute with the goal of finding defects. We want to make sure that the expected result matches the actual result, or actual result actually matches the expected result. And that's what we check. If the actual result don't match, we file that as a defect. And then we keep on evaluating, have we done enough testing? Have we done enough testing? That is called as evaluation of exit criteria. Once we know that enough testing has been done, all our prepared tests has been executed, the requirements are met, the stakeholders would be satisfied, then we go with a closure process. And during the entire software testing process, we need to be in control. the step or the process step is called as test control. Focus being that whenever things are not going as per the plan, how do we manage the project? That would be more like a project controlling mechanism for a testing project. Now this is a testing process. Now, since the topic for today was agile testing, we just discussed about testing in general. Most of you would be knowing this. Let's begin with the second term, which is agile. What is agile? What do you mean by agile? Again, here we are using MW or Merriam-Webster dictionary, and the full definition of agile is basically given here. Marked by ready ability to move with quick ease or grace, like an agile dancer. Second is, another definition is having a quick, resourceful, and adaptable character, like an agile mind. And there are examples of agile given, like for example, leopards are very fast and agile, or the expressive movements of an agile dancer. Now, if you look at it, agile definition is, again, if you take a look, ability to move quickly, fast, ability to change, all this comes into play. Okay. And then if you look at it, agile is being responsive to change. That's how basically the definition comes out. It includes the ability to be fast, ability to be nimble, to be adaptable, and to be flexible, like basically cheetah or like leopard, where if they're catching their prey, they're able to change their direction based on how the prey is moving. So it doesn't have a fixed plan. If the prey is moving and it changes the direction, cheetah or leopard is able to quickly, swiftly adapt their way and make sure that they can catch the prey. And that is the term which has come into our software development, because today's software development is not some hard-coded fixed one-year projects. We're talking about projects which can take or change its course depending upon how things move, how the surroundings moves, need changes, the requirement changes, requirements are not fixed. And that is where software processes are being agile nowadays. Now this is a quick agile recap, whatever I was discussing in software development. How do we ensure that our software development is quick enough or agile enough? If you look at this diagram, on the top there is a rectangle where the features are shown. Features are prioritized, they're risk assessed, and they're put in a bucket which is called as backlog. The highest priority feature, the top line features, are the one which are taken up first. They are basically expanded, the requirements are detailed out, and then those are developed. So if you look at the bottom, the first set of features are taken up and the entire development process takes around that, and that feature is developed. Then the second set of features are developed, and during the development things may change, the prioritization may change. So the second set of features which we have may change. Before we start the second set of features, we have the rights, or we have the agility enough to change what we want to basically do with respect to the changing need. And that is the beauty of the agile software. And in today's market, we talk about 83% of people and companies moving towards agile. If they have not, they're thinking about moving, and many of them have already moved towards agile development projects. Now, if we talk about testing or test design in Agile, how would it happen, by the way? So if you look at it, first of all, when a feature is being developed, you take that cycle as an entire software development cycle, where there would be some kind of software planning, then there would be some analysis, then coding, and then testing. So if I talk about the entire software development life cycle playing its own circle, that is what is happening here. Question is, do we need testing in an Agile project? Second question to answer is, would the testing be any different than any non-agile projects? Now these are critical to answer. Let's go back here and we see, first of all, do we need testing? Yes, I think so. And every one of you will agree that when a feature is being developed, there has to be a mechanism by which we can check, should we test here at the end of the increment, or should we be testing throughout the increment, or throughout basically the entire piece that is being developed? And how would the testing differ? Would it differ, by the way? See, if you look at the classic development mechanism and classic testing, the entire software development would happen in one go, and most of the test execution would happen at the end. Here, the software development is happening in pieces. The priority features are taken up first, and then the software development is happening. Second set of priority features are being taken up, and then software testing is to happen. Do you see the challenge? So when the second set of features are being added to the first set of features, it will definitely lead to testing of the first set of features as well. And that itself will lead you to think that as the features are added, as the software grows, the need for software testing grows. We need to be agile, we need to be fast, we need to be nimble, not only in the way that we change the requirements and adapt to that, but also in the way that we test. We should be able to conquer that the software which was tested and was working in the previous release keeps on working as it was, and it doesn't break away when we keep on adding the new features. So regression testing becomes a big risk. And in the process itself, the need for doing software testing has to be much more optimized. Okay. Now let's basically, this is what is being shown here again, testing in iterations. For every iteration, we need to test while it is being developed. And as the iterations keep on moving, the need for software testing grows. The need for regression testing grows. And that is where we need to be fast. That is where we need to be optimized in the way that we are designing the test. The way that we are executing the test should not be too wide, in the sense that we should not be taking too much time, because we don't have time. If we take basically a month to test before the new feature is added, then we won't remain agile, and the basic premise of agile software development methodology would not exist. Now let's discuss a specific term, and we'll come back onto that before we talk about the design technique, which is the core subject for today's webinar. Okay, what do you mean by test design? Can we optimize that first of all? So test design is to ensure that all requirements are met through a series of tests, increasing the probability of the software being capable of what is needed and wanted by the client. Let me again highlight some key points. First of all, test designing should ensure that all requirements are met, and the tests which are going to meet all those requirements will increase the probability of the software being capable of what is needed and wanted by the client. So test design should align with the goal of the software testing. Our design should be able to help us meet the requirements, increase the probability of the software, such that the needs are addressed, the wants are addressed for the client and the stakeholders. And the designing of this series of tests is nothing but your test design. Now the goal of test design is that we should have just enough tests, no more, no less. Because if we design too many tests, we'll be wasting the time. If we design less tests, then we'll be ignoring, and we will not be able to cover all the requirements, and we may miss some of the needs that the client may have. And this actually gels with agile philosophy. Just enough documentation, just enough test, do whatever is highest priority. That's how basically the entire agile philosophy is all about. Bottom line for any design or a good design is there is no time lost in writing redundant test cases that would unnecessarily consume time each time they are executed. In addition, the test suite will not contain brittle, duplicate, or ambiguous test case. Now, just to address this again, let me highlight that design should be just enough. That means that we should not have additional or redundant test cases. We should not consume extra time when we want to execute them. The test suite, the group of test cases that are derived from the test design that we have done, should not contain any test cases which are brittle. What do we mean by that? That if we test that something doesn't work, maybe sometime it works. So it is not basically that every time when we execute the test, we are not getting the same results. Not because of the software, but the way that the test has been written. The test cases should not be duplicate and ambiguous at the same time. So this is the basic philosophy of test design. Now, and there are multiple test design techniques that are in play. When we search the net, and I can highlight some of them. There's a technique called as equivalence partition. There is another technique which is built onto over that called as boundary value. Then there are other techniques like decision tables, state transition diagrams, and the design technique that we're going to highlight today is called as orthogonal arrays or pairwise testing, and sometimes it is also called as combinatorial test design technique. Let's consider a sample problem statement before we jump into the relevance. Let me make you understand the problem here that we are sitting on. Consider that we are testing a browser-based system. What is a browser? Browser is like Internet Explorer, Google Chrome, Firefox. So as the need may be, we need to test on 3 different browsers. And these browser can run on 3 different OSs. It may run on Windows, it may run on Linux, it may run on Mac OS, for example. We need to test for different speeds, the bandwidth availability, for example, 56 kbps, 256 kbps, maybe 1 mbps line. The web server that we have has got different 3 configurations that we want to test, JBoss or similar different web servers that we have. Application servers that we have may be different that we have, where we have got 5 different types of application servers. Database servers that we have may be different, like Oracle, DB2, Microsoft SQL Server, MySQL. Now there could be different database servers that we want to host or run or configure our software on, and we want to test on all of them. And the server OS on which the application server is running or where the application code is running can run on Linux, different flavors of Unix or Windows platform as well. Now, if we want to test such a system, the number of combinations should be how many? How many test cases and how many scenarios should be designed? So if we want to cover all combinations across all these combinations of things that we want to do, we have got 3 browsers, we have got 3 host OSs, we've got 3 different speeds or bandwidths that we want to test at the client side. We want to test with 3 different web servers. We want to test with 3 configured 5 application servers, 5 different database servers, and server OS are 5 again. The total combinations that we have run into around 8,100 different software configurations and environments that we will have to make, and then test the functionality in each one of them. So if one test takes 5 days, testing the entire software across 8,100 odd configurations, you can assume that the software testing will not end, and there's no way that we can finish this off. So how do we do this? That's where the beauty of orthogonal arrays and pairwise testing come into play. Because of the problem that we're talking about, that when we have different combinations to test, the combinations may explode, and the number of possible test cases can be huge with more number of factors or more number of variables. What is a variable? If you look at this diagram, browser is a variable, different host OS is a variable. So here we had how many variables? 1, 2, 3, 4, 5, 6, 7 different variables. And a combination of that led us to around 8,100 odd scenarios or combinations. Now, and it has been analyzed that typical defects normally don't arise from all the combinations. Normally it arises from single options for any given factors or pairs of options across pair of factors rather than triples, quadruples, etc. What does it mean? It means that when we are testing, normally the defect may happen because of pairing between a browser and a host OS, between pairing between browser and the speed, between browser and web server, between browser and application server, between browser and database server. Now that is how the combinations and pairing mechanism is all about. Okay, so how do we pair it? And the technique has been researched very well, and there are basically research papers and testimonials around orthogonal arrays and pairwise testing, which say that when we are using this technique and we want to reduce the total number of combination using this technique, 98% of the reported software defects in recalled medical devices could have been detected by testing all pairs of parameter settings. What does it mean? That if you're talking about testing medical devices and having basically different combinations of testing being done, rather than doing everything and achieving 100%, we could achieve 98% of the software defects captured by covering a small part of the overall combinations, and that is the beauty of our technique for the day. Now, orthogonal arrays and all pair tables are available, and there are ready to use orthogonal arrays on a site which is basically called as www.research.att.com and tilde njas oadir, and there are a library of orthogonal arrays there. This is an AT&T website where already existing orthogonal arrays exist, or there are free to use all pair tables which are existing. Both orthogonal arrays basically is an array or a matrix which are created and which can be used for our testing purposes. And if we don't want to use orthogonal arrays, there are a lot of tools that we can use which can create all these pairs, and these pair testing is equivalent to orthogonal arrays as well. The only difference between orthogonal arrays and all pair is the number of time each pair of option is represented, which is usually not important. So from a technique point of view, either we use pre-existing orthogonal arrays for our software testing, or we start creating all pair tables using tools which are free of cost, and there are a lot of tools which are available on the net as well. Now let's understand what is basically an orthogonal array. So if you look at it, on the right side there's a table, and if you know Boolean table or Boolean table, and if you have got two variables x and y, and if you want to create all combinations for it, then this is your 4 rows that will get created. Row number 1 0 0, row number 2 0 1, row number 3 1 0, row number 4 1 1, and these are all the combinations. But when we're talking about the pairs, and if you talk about all the pairs between two factors, this is an all pair table as well, or it's also simplest orthogonal arrays, because we have got two factors, we have got two options per factor which are 0 and 1, and each pair of option across two factors is represented in one and only one row. So 4 rows cover all the pairs between these two factors, which are factor number 1 or factor number 2. It could have been x, y. It could be two browsers that we want to test across two host OSs. That's how basically we're trying to create an orthogonal array. Normally orthogonal arrays are difficult to create. That's why we use pre-existing ones. So this is the simplest form of orthogonal array. Now let's take another example. When we talk about 3 factors or 3 variables, let's say that these 3 variables are x, y, and z, and we want to have basically an all pair table created for it. Now look here, if we talk about all the combinations with 3 factors having 2 values 0 and 1, the total number of combinations would have been how many? It would have been 2 raised to power 3, or 2 into 2 into 2, that would lead you to 8 rows. But when we talk about basically having pairs means that between factor 1 and factor 2 all combinations are covered. Pairs between 2 and 3 all combinations are covered, and all combinations between 1 and 3 are covered. So if you look at this table, if we say between factor 1 and 2, are we covering all the combinations? 0 0, 0 1, 1 0, and 1 1. Yes. So we are covering all the combinations between factors 1 and 2. Now if we look at combinations between factor 2 and 3, we are talking about 0 0 on first row, we are talking about 0 1 on row number 3, then we're talking about basically 1 0 in row number 4, and 1 1 which is on row number 2. That means that all combinations or all pairs between factor number 2 and factor number 3 are also covered. Now let's look at combinations or pairing between factor number 1 and factor number 3. Here we're talking about 0 and 0, then we have got 0 1, and we have got basically 1 1 and 1 0. Ideally in that case also all the pairs or all the combinations between factor 1 and factor 3 are covered. So in 4 odd rows or 4 tests that we have been able to cover all the combinations or all the pairs, sorry, for all these factors. Now this is basically a reduced table giving you all the pairs covering, and this is basically a larger orthogonal array, and that's why we say that in 4 number of test cases we are able to cover all the pairs. Ideally we would have to write 8 test cases. That means that in a normal testing scenario here, we would be able to reduce 50% of our testing efforts and still be able to cover 98%. This is a very simple example. Now in case if you're talking about our previous example that we were solving, and if we have all these combinations we want to reduce, we may go and get basically an orthogonal array which looks like this, which has got 1, 2, 3, 4, 5, 6, 7, 8 columns. It has got 49 rows. So the arrows denote how basically the rows are. And it has got values between 0 to 6. Now what we can do is, and there are only 49 rows by the way. So rather than, if you look at it, 8,100 combinations or rows, this orthogonal array can be used here, and we could basically have it reduced to 49 odd total test scenarios rather than 8,000 odd. And the way that we will do it, so just to give you the maths here, instead of 8,100 tests, we will reduce it to only 49 tests, which is 0.6% of the entire tests with 98% effectiveness. Let me give you the highlight again. So if we were doing this without orthogonal arrays, and to get 100% coverage by doing all the combinations, we would have created how many different test scenarios? 8,100. And if we select an orthogonal array with 49 rows, the kind of example that we have, rather than 8,100 tests, we could now do the entire testing by only 49 odd rows. So the total math here is divide 49 by 8,100, which and multiplied by 100, that will give you the percentage, and this percentage is only 0.6% of the entire set of test suite that we were trying to execute. And going by the research that was basically proving that if we use all pairs or orthogonal arrays which covers all the pairs for the combinations, we get 98% of the effectiveness. So 0.6% test covering 98%, and that is where the beauty is. And in an agile project you can see how much relevant this would be. So how do we do that? How do we use this orthogonal array for basically the combinations that we have? What we do is we look at the first column and we try to map the first column to the first variable, which is your browser variable. And wherever there is 0, we replace 0 in column 1 and we map it to the browser A. And whenever there is basically 1 in column 1, that means that we have to test for browser B. And then we keep on doing it for all the other columns as well. So for column 2 would be represented by host OS, and whenever there is 0 it will mean A, host OS, whenever there is 1 it is B, and so forth. So what would happen is that we will create a table of basically all these rows with zeros and ones replaced by the actual values of the browser, actual values of host OS, speed, etc. And we get 49 rows which will tell that for row number 1 you have to test browser A with host OS A, with speed A, with web server A, and application server A, and database server A, and with server OS A. That's how basically we will get 49 combinations rather than 8,100 combinations. Rather than using orthogonal arrays, which are ready to use arrays of 0 and 1 values, we could actually use some tools, which I am maybe in our next webinar, in our webinar 2, we will discuss how to use a tool. We will be able to reduce it to only 30 tests, and that will give us basically a effectiveness of 98%, and the number of tests reduced to only 0.37% of the entire test. Wow, that is the actual beauty of this particular technique. And in ideal cases, if the tools are even nice and the best of the breed tools, we can reduce the total number of test combinations to only 25, which means that by putting in only 0.31% effort for the entire testing, we get 98% effectiveness. Wouldn't that be nice? Now let's look at your relevance to Agile. Remember, we were talking about what are the testing challenges in an Agile testing setup. Let's say that in iteration 1 we had 100 test cases. In iteration 2, or when we are delivering the second set of features, we had another 100 test cases. And in another 100 test cases keeps on adding in every iteration. So at the end of iteration 4, if we do normal testing and if we keep on adding scenarios, the number of test scenarios will keep on adding. The effort required to do regression testing, because in iteration number 4, not only we test and we want to test execute the test relevant to that iteration, but we want to make sure that the earlier iterations also work fine, maintaining that test case is number 1, executing that again every time there's a new feature is added or we want to regress the software. The process is called as regression testing. The effort for this testing keeps on increasing to a level that it is basically unsurmountable by human efforts, and that is why we start talking about automation. But at the same time, if we have large number of combinations and large number of these testing things being done, the effort required to automate and the effort required to do regression testing either way, whichever is, whether we do it manually or whether we do in an automated manner, will still be humongous. It is not, and we say next to impossible. And to give you another flavor of how things are, let's take this example. We have got basically a combination of different things going on. The example here is for an online mortgage application. And if you look at it, we want to say that the online mortgage application behaves differently if somebody applies loan in particular region, different tier of house that they want to buy, different type of properties they want to buy, different credit rating that person has, different type of residences they want to buy, and loan to value, LTV is loan to value, how much basically the value of the property and how much loan we want against that. Then no income verification, whether it was done or not, net asset value, whether it is done or not, whether it is a refinancing mortgage or not, what is the closing cost and who would bear the closing cost, whether it would be the customer who would bear the closing cost or whether it would be the bank who would bear the closing cost, what is the intro rate that we have, and who's basically, is the person applying for the loan a bank employee or not. Now if we take this testing to be done, the total number of scenarios that we generate runs into almost 725,760 odd combinations. And with the best of breed pairwise testing tool, this number can be reduced to only 42, which is only 0.0578% of the entire lot. This, and your effectiveness is again 98%. Now, let's go back to our original goal that we have. We said just enough tests, no more, no less. So, is this 0.00578% test enough? Ideally, yes, because we are covering 98% of the entire defects that could have been detected had we done the entire combination of testing. Because if you want to do all the combinations, every combination, if I take basically an R, and if you multiply it by this number, then the total number of combinations will be humongous. Alright, so that's what is the goal here. We are saying orthogonal array and pairwise testing is by far the most powerful technique, more useful for agile projects than any other project. With this, I'm going to thank you all for attending this webinar that is being brought to you by Agile Testing Alliance, and we'll open the questions. I'm just going to take a pause here, and then we will basically go back and answer all your queries.